All right, so this section won't be anything new because we actually did this first semester quite a bit. But I wanted to go ahead and revisit the idea of estimating the area under a graph. And of course, we did this a lot with distance, having velocity graphs and knowing that distance equals rate times time. And that's why we found the area under the curve. So that's kind of your more practical application for why we do this. But I just want to revisit, we're going to set up our Riemann sums, and I want to revisit how we do that. So we have this curve right here. It's the graph of let's see, it's the graph of 1 plus x squared. So it's x squared shifts it up 1. And you are being asked to first find the area under the curve, or estimate the area under the curve, with 5 rectangles from 0 to 5. So one of the first things we want to do is we want to ask ourselves, what is the change in x? So our change in x is going to be from our rightmost endpoint to our leftmost endpoint divided by how many rectangles we're using. So our change in x in this case is going to be 1. So that means to get the next endpoint, we're always just going to move a distance of 1. And if we're using right endpoints, well then that means we don't start at 0, so we have 0, 1, 2, 3, 4, 5 if we go by ones. But if we're doing right endpoints, we want all of these and not the furthest left one. So I'm going to start at 1, and I'm going to go over to the curve, and I'm going to go up and over, and that would be my first rectangle. Then I go over a distance of 1, and I go up to the curve again and over. So I'm going to do my 1, 2, 3, 4, 5 for my widths, and then I go find the corresponding height. And then I can find the area of all 5 of those rectangles and add them together, and that's going to give me an estimate of this. So to find the area of all of those rectangles, basically all of them have a width of 1. All of these have a width of 1, but they all have a different height, and that height corresponds with the function's value at each of those endpoints. That's how we're getting the height here. So like this height right here corresponds with f of 5. So basically, I have length times width plus length times width plus length times width and so on of the 5, but since all of them have the same width, I can go ahead and just pull the width out. So I have the width of 1, or our change in x, times our summation here of f of 1 plus f of 2 plus f of 3 plus f of 4 plus f of 5. All right, I'm going to ask you guys to go ahead and pause the tape right now, or pause the video, and grab your graphing calculator, plug your function in, and go to your table. Start your table at 1 and go to 5, and then you're going to be able to get all those values, and you'll be able to add them all up. Okay, so go ahead and pause it. All right, so now that we've done that, what I want you to do, or what I want you to notice, is that when you added all of those different functions, the y values for 1, 2, 3, 4, and 5, you got 60. And our change in x in this case, as we already said, or we noted up here, is 1. So we're going to go ahead and plug in 1 for that. So we'll just have 1 times 60, which is 60. So we have an estimate of 60 units squared for the area under this curve. Hopefully looking at this, you will notice that this is an overestimate because we have more over the graph than what we want. So if we want to try and get a little bit closer estimate, we could go ahead and do 10 rectangles, which means that my change in x would equal 5 minus 0 still, but over 10 this time, or 1/2. So I would have 0, but then my next endpoint would be a half, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, and 5. And again, if I'm using right endpoints, then I'm going to get rid of the first one and use all the remainders. So similarly, it'll be change in x, but then it'll be f of 1/2 plus f of 1 plus f of 1.5 plus f of 2 plus f of 2.5 plus f of 3 plus f of 3.5. And this gets to be quite tedious, which will make you appreciate our other method. And lastly, f of 5. Wow. All right. So again, I would suggest that you pause the tape, go ahead, or the video, go ahead and go to your table. And this time you're going to set it at 1, but you're going to go by halves. Or sorry, why don't you start at a half and go by halves. And then that way you'll get all the corresponding y values from 1/2 to 5. So go ahead and pause it and do that. All right, hopefully you found those to be, when you added all of those up, 106.25. But again, we're taking that times our change in x, and this time our change in x, sorry, it's 106.25. This time our change in x is a half. So I'm actually going to take a half times our 106.25, and that gets me that gets me 53.125. And that's a little better estimate. And if you want to see what those rectangles would look like, I'll draw them in here in green. And you'll notice that I have less coming off the top when I do these. Oops, that one went up a little high, sorry. All right, so that would be, so we have less going over. Like if you look at the green, we have a lot less than what we did with the red. So this is a little closer estimate. So the question would be, how many rectangles do you think that we need to have in order to have the exact number, or the exact area under the curve? And we discussed this and looked at this, and we determined that we needed to have an infinite number. So we're going to get into how to do that. Okay, we don't just have to find right endpoints, we can also use left endpoints. And in this case, I'm not going to do both. I'll give you the answers for both and you can verify. But the idea behind the left endpoints is that instead of, so again, we're going to go from our change in x, if we're going to do 5 rectangles, would be 5 minus 0 over 5. So that's 1. So it's our change in x. And so that means we have 0, 1, 2, 3, 4, and 5. But this time if we're going to do left endpoints, we want to include the left sides but leave off the right. So I'm going to go from 0, that's my first rectangle, over to 1. Then I'm going to go up and just keep going over by ones. And so if you notice, I'm going up on the left side this time. And this is obviously an underestimate. So again, we know we're going to have change in x times our summation of f of xi and our f of x star. So this is our summation, and we know that we're going to have 5 of them. 1 to 5. So if you guys want to do the same thing we did before and just do it on the table, but this time we're going to use f of 0, 1, 2, 3, 4, instead of using the 5, the 1 through 5. And when you do that, you get 35 for your area. Now you can do the same thing with the left endpoints using 10 rectangles where we found our change of x is a half. And as you notice, I'm having less and less stuff missing underneath. I'm getting more of the stuff that I need there. So this would be an even better estimate, but it would still be an underestimate. So for this one, we'd have our change in x is again a half. And we'd have our change in x times our summation from 1 to 10 this time, because we'll have 10 rectangles of our function. And again, you're just going to plug that into your calculator. And for this case, I got 40.625. Okay, so we have overestimate using 5 rectangles, overestimate using 10, underestimate using 5, and underestimate using 10. So the question is, can we get an even better estimate? And I'm just going to do this with 5 rectangles again, but I'll actually show you that we can get a better estimate even still using only 5. And the other thing is I want to introduce you to a notation. When we use right endpoints with 5 rectangles, we say R5. So just to review, R5 for this case was 60. And then if we use the left endpoints in 5 rectangles, we put L5, L sub 5, and that was 35. Okay, so now I'm going to show you how to find the midpoint. We're going to use the midpoint rule, or use midpoints, and we're going to see what that looks like using 5 rectangles. So if we're going to do midpoints, again, we still have our change in x is 5 minus 0, and I'm going to use 5 rectangles, so the change in x is 1. So we would have 0, 1, 2, 3, 4, and 5. But now if we're going to do midpoints, that means I'm not using any of these values. Instead, I'm going to use the midpoints, the numbers between each pair. So I'd use 1/2, 1.5, 2.5, 3.5, and 4.5. So those are my 5 rectangle heights. So what does that look like on the grid? Well, I go to the midpoint instead and I draw my rectangle. So here's the midpoint and I draw my rectangle. Go up to the midpoint, draw my rectangle. And do you notice that each rectangle is going over and under? So we're missing some on the down or on the underneath side, and then we have some going over on the top. Let me show you more what I mean. So with this first rectangle, this guy here, well, that one's hard to see. Let's go to one of these other ones. Do you see how this is missing, but this is extra? So again, this is missing, but this is extra. So this kind of helps us even out those over and under estimates. And it works really well for an increasing or decreasing graph, but it does not necessarily get you the best estimate always. So don't be deceived by that. Okay, so again, we'd have change in x times, and we'd have f of 1/2 this time, plus f of 1.5, ... And you can use your calculator again, and this time I would just start my table at 1/2 and do my change in x as 1 on my table and take the first 5 values, and that'll get me my heights. Now when you do that, you should get, for a final answer, 46.25. So this right here would be 46.25. And if you notice, we said that this was an overestimate, this was an underestimate, and this is a little more accurate. And I hope you see that that is the average of those two. Again, not perfect, but close. Sorry, my phone is ringing. Sorry about that. Okay, so this is where we're sitting. This is what we have. Hopefully these 3 rules work for you or it makes sense. I think the biggest issue is to understand when you have an overestimate or an underestimate, and we still need to look at how do we make this fit to find the exact area. But you should have enough at this point to be able to do your homework on section 5.1.